Good morning. This is the last video for AP Stats Chapter 8. We are finishing up Section 8.3, where we talked about using the PANIC acronym process to find the confidence interval for a mean. So today, just like we did with proportions, today it's about determining how big a sample we need to take. So here's a question. How big a sample size should I use? I want to create a confidence interval for mu, the mean gas mileage of every car in Colerain Township. I want my margin of error to be plus or minus 2 miles per gallon. And I want 95% confidence. How big a sample? Well, there's the formula for the confidence interval for a mean. It is X bar, which is my sample mean, plus or minus the margin of error, which is that T star number. Remember, we have to use that T distribution since we don't know sigma, times the sample standard deviation divided by root n. That's the formula for the confidence interval, and this margin of error, which I have it in blue there, is what we're going to have be within 2 miles per gallon. So here's the inequality I would want to solve for n. And again, n is ultimately what we're looking for. How big a sample? The problem with this inequality is twofold. It says two problems. That T star number, remember we said that depends on the sample size, like that T distribution changes for different sample sizes, and I don't know my sample size. And Sx is my sample standard deviation, which I also don't know. So there's no way I can necessarily put in numbers for T star and Sx, but I would need numbers there in order to solve that for n. So we kind of have to do the best we can do. You may recall for proportions in this same process, determining sample size, we needed back then for in 8.2 for proportions, we needed a p-hat, which either we used prior knowledge or we used 0.5. Like that's how we got around that formula with proportions. Well, with means, we have to worry about the T star and the Sx. So here's how we're going to handle that. It says the best we can do is this. For the Sx, we're going to have to just have or use, not make up, but somehow have some sort of prior knowledge of an older population standard deviation, sigma. And then for T star, we're going to have to just use the Z star. And we know Z star numbers. That's just right out of our calculator. It was 1.96 for 95%, et cetera. So we're going to take this red, the inequality we want to solve, and we're going to replace it with this blue one, which is now kind of the best we can do. We know a Z star number for 95%, and we're going to have to be given some sort of prior knowledge. So it's not ideal. There are more advanced statistical ways to get around this, but they're beyond the scope of this particular class. So having done that, now we can put in the right numbers and actually solve for n, which I'll do here in one example. So here's the same example. And again, for 95%, we know the Z-score is 1.96. And let's say we're told that a prior sigma is 4.9. So I plug those numbers in. 1.96 times 4.9 over root n is less than or equal to 2. And then you just have to be really careful doing the algebra. I think I did the algebra on the next slide. So first, I think I multiplied the root n to the right side. That's this line here. Then I divided both sides by 2. That's this line here. Then I squared both sides. That's this line here. And I end up with n is greater than or equal to 23.06. And remember, we're always going to go up to the next integer. So my sample size would need to be at least 24. So that's it for that. Real short video, just determining sample size for a confidence interval for a sample mean. Real short assignment today, which is these three, just involve finding a sample size. And then before this week is over, I want to do two quick things. I want to do a real quick review of PANIC for a proportion, sample size for a proportion, PANIC for a mean, sample size for a mean. I want to do a real quick review and a quiz over those just to get them done. And I actually want to start chapter 9 just because when we get back on April 12th, we're kind of pressed for time. So that's the plan for the rest of this week. So I'll see some of you in class later this afternoon. The rest of you, I will continue to see virtually. Have a great day.